All right, chaps. Today we will speak about the strong force and its evolution. I will not use a British accent. We're going to go through a little number theoretical study, factualization, some map making, some principles of cartography for the subatomic scale in terms of the logic that is used by the quantum walk and its various navigational faculties. Bearing in mind that 000 has its complement in 999, all the particle states are splits of 999, because 9 is the quantitative form of 0. 0 is a value that if you add it to, the front or the back of any number is going to shift the magnitude, but it's not going to shift the quality of the number. So 000 and 999 are this fabulous pairing at the very center of things. And so when I speak of symmetrical particle masses, it's because of this rule or this requirement that is how the light cone discretization functions. When you split 9 into 1 and 8, 2 and 7, 3 and 6, or 4 and 5, it's just like splitting a 0 into a +1 and a -1, +2 and a -2. And there are obvious and less obvious forms of tensional components that connect these numbers, these complementary values, when they are partitioned. For example, when you separate a 1 and an 8 from a 9, the obvious tensional component between the 1 and the 8 is the number 7. But since 7 is paired with 2, the less obvious component between the 8 and the 1 will be 2, because 8 plus 2 gives you 1. When you do this with 7, and then the obvious tensional component is 5, the less obvious one is 4. Because obviously 7 minus 2 is 5, but 7 plus 4 gives you 2. When you do this with 3 and 6, you see that the obvious tensional component between 3 and 6 is 3. The less obvious one is 6, because 6 plus 6 gives you 3. And lastly, when it comes to 4 and 5, the obvious tensional component would be 1 that connects those two. The less obvious one would be 8, because 5 plus 8 gives you 4. Okay, in the evolution of the strong force, it's the splitting of the 9, the photonic 9, into these gluonization constraints of 3 and 6, which are anchored by the strange quark. The strange quark is the principal flavor for hadronization. And they know this very clearly now from the quark-gluon plasma experiments and everything else. Strangeness is the dominant hadronizing flavor. And it just so happens that to support SU3, the actual flavor numeric construct and absolute form of concision identifies the strange quark with the number 3. Yeah, it is certainly the number 3. Its anti-state would be 6. But so we see these 3s and 6s at work when we look at the rho meson component within the nucleon, because the nucleon is up, up, down, whereas the rho meson could just be a U anti-U, up anti-up. And that up anti-up state has a mass value of 771.228. In contrast with its light pion form, which is 134.865. you say, well, I looked up the light pion and it's 134.9. It's not 134.865. And just remember, it's the symmetrical value of 134 and 865 together that give you 999. And so that's where that signature comes from. It's annihilation symmetry. Well, the connection between 771228, which is the row, and the light pion form 134865 is 636363. If you look at the relationship between the bottom anti-bottom state of upsilon at 946053, its complement in this same example would be the J-psi state of charm anti-charm at 309.690. The difference between those two being 636363. Coincidence? I think not.